Alright guys, welcome to Colossus mathematics class. In today's class we'll be talking about complex analysis. So in today we'll be talking about polar form of complex number. Don't forget this is a playlist on its own, so you can check other topics before this so you can have a proper understanding of this. Now, before we go to polar form, don't forget that the standard way a complex number is written is x plus I y. Now, if I want to put it in polar form, I have my theta here. The theta is known as argument. Theta is known as argument. Now, look at this. If I want to get my sine theta here from here. Theta is what? Opposite over what? Hypotenuse, abi? This is my opposite, this is my hypotenuse. So this will be opposite over what? Hypotenuse, abi? Now if it is cos theta is what? Adjacent over hypotenuse, abi? So adjacent x, hypotenuse adjacent over hypotenuse. Now if you cross multiply to make y equal to formula, that will be y equals to r sine theta, and this one what? X will be equals to what? R cos theta. Now, if we are replacing it here, if we are replacing it under our standard complex number form, I have x plus iy. Now that will be what? Z equals to what's my x? My x is what? R cos theta plus what? I r sine theta, and that means our z can be r cos theta plus I sine theta. Now where your r, how will you get your r? Using Pythagoras theorem. Using Pythagoras theorem, your r will be what? X squared plus y squared. Square root like this. Do you remember? Don't forget Pythagoras theorem is hypotenuse square equals what? Opposite square plus adjacent square. Adjacent square plus opposite square. So that is it. Then our tan theta. Our tan theta is always sine theta over cos theta, abi? So this sine theta over cos theta, and you can see our tan theta is y over x. So these are the normal standard formulas we need to know. So this is used when you want to find argument. So if you want to find your argument will be what? Theta equals what? Tan inverse of what? Y over x. Do we get that now? So let's see a few examples on this. Let's see a few examples on this particular topic before we wrap up for today. So don't forget to subscribe, like, and share this video. All right, example 1. So let's say I have example 1 here. It said find the arguments. Find arguments if our z is equals to minus 3 minus 4i. Now I want to find the arguments. How are you going to get the argument? It is very, very simple. Now don't forget I said to get argument you use theta equals what? Tan inverse of what? Y over what? X. I get what I'm saying. Now you have to first go to get your what? Your y, and you know your y from here. Z equals to x plus iy, and we have z equals minus 3 minus 4i. So from there you can say that your x is minus 3 and your y is minus what? 4. I get what I'm saying. So that means your theta will not be what? Tan inverse of what? Minus 3. Okay, that's minus 4 first over minus 3. Abi? So yes. So now that will not be theta equals to tan inverse of 4 over 3. 4 over 3. And that will be tan inverse. Now, 4 over 3. So let's just do something very quick. 4 over 3 will give us, so on my calculator, 4 over 3. 4 over 3 is 1.3. 1.333. Now, tan inverse of 1.33. So our theta will be tan inverse of 1.33, as you can see here. So tan inverse, how do you get tan inverse? Shift and tan of 1.33. So that is 53.06. So 53.06. Now, this is our theta. Now, the next thing you have to do, here is that this one cannot be under the third quadrant. Under the quadrant, it's under the third quadrant that tan is positive. Tan is positive under the third quadrant. So for you to put it under the third quadrant, say this one should be alpha. So let alpha be 53.06. So your theta will now be 180 plus 53.06. Then your theta will now be, if you add this to this, it will give you 233.06 degree. So this will be your argument. Do you understand that now? All right. So let's see some examples on polar form also. So this will be your argument. So don't forget the process. You get your x and y, you divide it and get the tan inverse. Then if it is not under third quadrant, you add 180 to it for it to be under your third quadrant. All right. So let's see some example under polar form. So let's see, I have z. Let's say I have z equals to 1 plus I. So if I'm told to put this one, this is in complex number form. So if I'm told to put it in polar form, how will you do it? It's very simple. Don't forget the polar form is what? R open bracket cos theta plus what? I sine what? Sine theta. Now, the first thing you will need to get is your R. You need to get your R. How will you get your R? Your R is your square root of x square plus y square. And that will R equals, what's your x here? Your x is 1. So that's 1 square plus, what's your y? Your y is also 1 square. And that means your R is equals what? Square root of 1, which is what? 1. Do we get that now? Now, your R here, okay, 1 plus 1 here. 1 square plus 1 square, that's 2 here. So that will be square root of 2. Alright, so the next one now. We've gotten our R, then let's get our cos, our theta rather. How will we get our theta? Our theta is what? Tan inverse of what? Y over x. And that will be tan inverse of what? 1 over 1. And that will be x equals to tan inverse of 1. Abi. Now, your theta will be the tan inverse of 1. So let's use our calculator to get the tan inverse of 1. So you use your shift and the tan of 1. So that will give us 45 degree. So that's 45 degree here. Now, how will we now put it in polar form? Now the z equals, what's your r? Your r is square root of 2. Square root of 2, open bracket, cos 45 degree plus I sine 45 degree. So this will be your final answer. So you can leave it this way and you can also open it. You get. So you can also go ahead by trying this particular example. So let's say I have z to be 2 minus 4i. So you can go ahead and try this example and give me the answer in the comments section. There'll be something for you there if you get the correct answer. Thank you very much. See you next week.